Namaste students, welcome back to Rama Teaches You. Today we are going to do the fourth video on the physics chapter, class 11th, laws of motion. Okay, in the previous video we have already discussed the static friction and the sliding friction. Okay, now in this topic we have to do rolling friction. Okay, what is rolling friction? So the force of friction that comes into play when a body rolls over the surface of another body is known as rolling friction. Okay, now for example, a wheel rolling on a ground is a type of rolling friction. Okay, when we basically try to move a wheel on the road, what happens? It moves for a while, but afterwards it slowly comes down to rest. It comes down to rest, right? It does not keep on going over and over. Otherwise, every single cycle, when you start pedaling it, it should just keep on moving, but it does not. Why does it not move? Because there is another type of friction called the rolling friction. Okay, so when a wheel, a circular disc, or a ring, or a sphere, or a cylinder roll over a surface, the force that opposes it is called rolling friction. Okay, the force that opposes the normal motion is known as rolling friction. Now, normal motion of what? A circular object basically moving on another surface by rolling over it. A rolling friction is much less than static friction or sliding friction. Okay, static friction has the highest magnitude of all the frictions, but rolling friction is much lesser. It is lesser than sliding friction also. Okay, the roll when a wheel rolls without slipping over a horizontal plane, the surface at contact do not rub over each other. Okay, how do you observe this? Look at these to my hands. Okay, this is a surface. Okay, for now I'm going to consider this surface also to be circular. If you roll an object over another surface, what do you observe? Every single point of time you have only a small point of contact, right? You have a small point of contact. Look at this. When a circle is rolling over another surface, it only has a small point of contact at any point on the surface. It's not like sliding friction where the area is larger. Okay, you only have one small point of contact. Now the rolling friction is much less than sliding friction, and this is why the vehicles run on roads. When a wheel rolls without slipping over a horizontal plane, the surface at contact do not rub with each other. The relative velocity of the point of contact of the wheel with respect to the plane is zero if there is no slipping. There is no sliding or static friction in such an ideal situation. What is one thing that we have to understand very clearly is that sometimes you have sliding also taking place when you are rolling over a surface. Okay, for example, what does it mean? You are going through a road. Okay, in your car, you're going through a road in your car, and you basically start to move over some sand or ice. What ends up happening? The wheels of the car slowly start to slide. They're not able to get the grip. Once you don't get the grip, what happens? Your wheel starts to slide at one single point. You live in the desert, right, Drupad? You must have observed this. Sometimes when there is sand on the road, what ends up happening? The car's wheel actually slips before it gets its grip again. Okay, so in when we are studying rolling friction, we are not gonna assume sliding happening. Okay, the wheels are not gonna slide. The wheels are gonna be in constant contact with each other with relative surface velocities to be zero. Right, the wheel and the surface will have zero relative velocity, no movement at all. It will only touch, and the next part it will only touch and the next point will come in contact with the surface. Okay, there is no relative motion. Now the rolling friction is this thing. Okay, now there is no sliding or static friction in such an ideal situation. We need to overcome rolling friction only when only which is smaller, much smaller than sliding friction. For this reason, wheels have been considered as one of the greatest inventions. People in the olden times, when they saw a branch or a trunk, a tree actually falling down a hill, they observed that what the whole this thing, the whole trunk was basically moving much more faster than an ideal stone would have, having the same weight. Why? Because it was rolling down the hill. They observed that and they realized that, oh, if something is circular, if something is circular, it becomes easier for us to roll it. Instead of sliding it, it is easier to roll it, right? That's where the invention of the wheel actually came from. Cause of rolling friction. Let us consider a wheel rolling along a road. As the wheel rolls, it exerts a large pressure due to its small area, right? So basically, if you have a wheel like this on a road, there is barely any point of contact between the wheel and the road, right? Barely any point of contact. So what happens? The weight of the wheel and the vehicle, what happens? It gets concentrated on a very small area, thus increasing the pressure at that particular point. Okay, you are increasing the pressure at that particular point. So what happens? The area of contact between them due to this high pressure deforms itself. It just deforms itself, and you get such a depression on the surface where the wheel and the surface meet. You get a small depression. Can you see this, Drupad? See, this is the depression, right? Can you see it? Okay, fine. So this causes a depression on the surface below, and a mount or a bump in front of it is shown in figure. In addition to this, the rolling wheel has continuously detached itself from the surface on which it rolls. Now, when you're wearing when women wear heels, okay, what happens when they walk over a grill? Have you ever seen, like, I'll give you another example. If you are a football player, okay, you are wearing those spiky things and you're trying to go through a place where there is a lot of holes there. Okay, sometimes what happens? The heels get stuck. The heels, they get stuck on the road. So basically, you have to exert more force to remove your feet from that surface, right? Every single time you get stuck, you have to apply more force to come out of that depression. To come out of that stuck area, you have to use more force. Similar, something like that is happening here. Every single time the wheel is getting in contact with the surface, because of the small area of contact, it is causing a lot of pressure on that contact, due to which what happens? Due to which the surface gets depressed. And because of this depression, what happens? The wheel has to overcome, it has to come out of this depression every single time, and this whole thing requires some amount of force. Okay, so the force required to overcome this coming out of the small depression every single time is called the rolling friction. Understood why we have the rolling friction in the first place? So what is happening here? On the account of these forces, so basically this is opposed by the deformation of the two surfaces in contact due to adhesive forces between them. On account of these forces, a force originates which retards the rolling motion. Okay, it retards the rolling motion. This retarding force is known as rolling friction. Now, Drupad, think about this. You have a toy car. Do you remember those toy cars in the back? Basically, when you basically pull them backwards, and there is a small spring in the car which basically coils itself, and then when you release it, the car moves forward. If the surface is flat, if the surface is flat, the car will move for a longer duration. But if there are bumps on the surface, what happens? Will it be able to move the exact same distance? No, right? Because some amount of energy is being lost to overcome those bumps, right? I'm just giving you a like an example that in which you can actually see what is happening in rolling friction at a microscopic level. Okay, every single time the car overcomes a bump or a hole or a bump, basically it is losing its energy. When it is losing its energy, it has to basically overcome, it has to overcome these bumps by using some amount of work. So force is basically happening to overcome these types of difficulties. And that type of difficulties, that force is known as rolling friction. Sorry. Okay. So ways for reducing rolling friction. The various ways of reducing friction are: number one, lubrication. Okay, whenever I ride a motorcycle, what did I do? So first things first, I will basically service it every 6 months. I service it. What do I do in that? I basically change the lubricant on the what do you say? What do you call them? Um, belt? No, not the belt. On the chain, right? Yeah, exactly. I change the lubricant, and then because of that, what happens? The chain moves faster, the gears move faster, the engine is filled with engine oil to lubricate the engine, the gearbox is filled with liquid and grease to basically make the movement really, really easier. Have you ever skated before, Drupad? Skating, some, yeah. So, have you ever played with a Fitbit, fidget spinner? Right, a fidget spinner, what does it do? Basically, it is nothing but a ball bearing, right? I have opened the fidget spinner. When I put some oil in it, it starts to rotate even faster. Why? Because I have added extra lubrication in that fidget spinner, because of which what happens? The rolling friction reduces. Okay, rolling friction. So any type of friction can be reduced by lubrication. Any type. Okay. Now, even the carom board also. What do you do? Before you playing caroms, what do you do? You powder the whole board with talcum powder, right? What does the talcum powder do? The talcum powder actually goes inside the basically what do you call them, irregularities of the surface. They go into the irregularities of the surface and they fill them, due to which what happens, the irregularities on the surface gets reduced, due to which friction decreases. That is also a type of lubrication only. That's a solid lubrication. Okay, liquid lubrications, we use them in engines, we use them in door hinges. Okay, lubrication reduces friction and wear and tear. Next, polishing. They are used to make the surfaces very, very smooth. Smooth surfaces have less number of irregularities, due to which what will happen? The friction will also reduce. Polishing. They're used to make the surface again smoother. Okay, basically your polishing is done. Then ball bearings. The ball bearings arrangement consists of two coaxial cylinders. Okay, have you ever seen a ball bearing? That the same thing that is present in the fidget spinner. Okay, the small round thing is called a ball bearing. Okay, you have two cylinders, an outer cylinder like this and inner cylinder here. The outer cylinder and the inner cylinder have gaps between them that are filled by metallic balls. These metallic balls basically they rotate themselves. If you want a ball bearing to rotate forward, what happens? If you want to rotate forward, these balls will rotate in the backward direction. Okay, for allowing the forward rotation of the actual bearing. Understood? So rotation, we all know, as we all know, rotational motion has the least amount of friction, right? Rotational motion has the least amount of friction. So ball bearings are a very good invention. Okay, they allow two surfaces. Okay, they allow two surfaces to be in contact in such a way that one surface's motion can be translated on the other. Okay, that's how skates work. Okay, you are applying your force on this small area. Okay, initially you're applying force on this small area. This force is being transferred into the bearings, and these are then transferred into the tires. These are then transferred into the tires. So basically, you are having a bearing contact. Ball bearings are transferring the force from the inner axle, which is being provided by you, to the outer wheels. Okay, this is how ball bearings work. A thin cushion of air is maintained between solid surfaces in relative motion. Have ever played air hockey, Drupad? Air hockey in the malls and all, in the gaming center, you have air hockey, right? What is happening there? small gust of air is released at the bottom. There are a lot of holes on the air hockey table, right? There are a lot of holes on the air hockey table. So what happens is there is a small gust of air coming from beneath the table, due to which what happens, there is a small air cushion, and the striker that is placed on the this thing on the air hockey table basically is floating. It is floating between the table and that. Okay, due to this air between them, it is floating. Okay, and this air cushion reduces because they are not physically in contact with each other. The resistance is reduced to a large extent. That is the reason why the striker moves really really fast on the air hockey table. Understood? Okay. Okay, and finally, streamlining. Friction due to air is considerably reduced by streamlining the shape of the body moving through the air. Every single vehicle that we have designed is streamlined. Every single vehicle. There are some vehicles that are poorly streamlined, but every single vehicle that is, trying to move really, really fast through air has to be streamlined. For example, the Shinkansen, the Japanese train, it has. Have you ever seen the beak of a Shinkansen, the bullet train? It looks like a hummingbird's this thing. What do you call it? Hummingbird's beak. Why? So that it can tear through the air. Okay, it has a streamlined shape so that it can tear through the air and go at ridiculously fast speeds. Okay, it is going at ridiculously fast. So basically, it can go up to a speed of like I think 350 kilometers normal working time, and like 500 or something like that when it is experimental. Now, if you want to move really fast through air, you have to overcome another type of frictional force called drag. Okay, and the drag greatly increases as the speed increases. Okay, the more faster you travel, the more drag you will face. If you have ever ridden a bicycle, you must know that every single time you try to pedal really, really fast, what happens? The air is getting pushed onto you much faster, right? When you're traveling really really slowly, it is easier, but as your speed increases, the air resistance in front of you increases a lot. You would experience this more if you riding a motorbike. Okay, a motorbike is basically like when I ride a motorcycle, I usually, if I want to travel really really fast, I basically hinge myself. Okay, I'll go down and then I travel like this so that the air resistance reduced to a much larger extent. That is known as streamlining. Not just for air, even the boat. Have you ever seen the shape of a boat? It is always basically an arrow. It's like an arrow design, right, inside the water, so that it can basically tear through the surface of water as it is moving forward. Have you ever seen a boat that is basically like flat in the front? You will never see a boat that is flat, absolutely flat at the front. Why? Because that's a bad aerodynamic design. It's a bad streamlined design. Clear? Similarly, even submarines also, when they go through a fluid, they have the shape similar to that of a whale or a dolphin, right? Why is it that? Because those bodies have been adapted by nature over millions of years to actually flow through the water with ease. Okay, so that is known as streamlining. Understood? Is it clear? Drupad, is it clear? Okay, now what is the fastest object that you have ever created? Fastest vehicle that we have ever created is the rockets, right? Basically the rockets that go at Mach 10, Mach 8, all these ridiculous speeds, right? So again, there they have to literally tear through the whole of the air so that they can move really really fast to reduce the air resistance. Now Drupad, you know one thing why we do streamlining in the first place? We do streamlining in the first place so that the obviously the drag reduces, but you know what is the result of this drag? It is friction. Drag is also a type of friction only. And when you have friction, what happens? Every time you have friction, the heat also increases. Okay, because of this friction. This is one of the major reasons why most of the like meteorites and comets, as they come into the Earth's atmosphere, they experience, because they are not streamlined, they experience very large amounts of air resistance, due to which what happens, they burn themselves out. A hard chunk of matter is burning itself away in the Earth's atmosphere, right? Because of this air, we are protected by the meteorites. Okay, let's actually move on. Dynamics of circular motion. Did you understand the logic why we do streamlining? Okay, let's move. Now, dynamics of circular motion. When a body moves on a circular path, its direction of motion at any instant of time is along the tangent to the circle. On account of its motion, if the speed of the body remains the same and its direction of speed changes continuously, then there is a velocity change of the body, and hence it undergoes an acceleration. We know this, right? Even if you are traveling with a constant speed in a circular path, the constant directional change leads to constant velocity change, because direction is also a component of velocity. So the object will undergo acceleration. Okay, it will undergo acceleration. Now, this type of acceleration is known as centripetal acceleration or radial acceleration. The acceleration is acting inwards. Okay, whenever an object moves around a circular path, the acceleration is acted inwards. It is being acted inwards. This is known as rotational acceleration. This is providing a force to the object called the centripetal force. Understood? What is a centripetal force? A centripetal force is a force which acts inwards. It is directed inwards. Understood? Clear? Okay. One second, Drupal. Can you actually hear me in live? Like, is there a delay here? No, right? It's fine. Okay. Let's move on. Now, thus, according to Newton's first law of motion, a body cannot be accelerated by itself. It requires a certain amount of force from the external environment for the object to accelerate, right? It cannot accelerate by itself. It has to require some amount of force from the external resource. Now, this external force is called the centripetal force. The object, when it is traveling in a circular path, it is accelerating, and this acceleration is basically helped by the external force, and this external force is known as centripetal force. Okay, now this is how it looks like. Okay, so in a circular motion, any point of time, the direction of acceleration will always be tangential, or will always be parallel to the it will always be tangential to the path. Okay, now look at this. For example, if an object is traveling like this, okay, it is traveling like this. Now, at any particular point of time, the direction of that object will be a tangent. It will move exactly like this. Okay, here it will move like this. 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 Always it will be a tangent at that path. Okay, so it's like even if the sun vanishes the very next second, what will happen? Like after 8 minutes, we will basically not see the sun anymore, and due to which what will happen? The gravity will stop affecting us. Due to which what will happen? The sun will move in a tangential path away from its orbit. Understood? At that particular point of time, the point where we observe the sun to disappear will be the point of time where we basically start moving in a tangent. Understood? So even if, like, basically there used to be weapons in olden times, people used to, rotate an object really, really fast, and then they will release the object at some particular instant, due to which what will happen? The object will move straight outwards. Understood? It will move straight and in a tangential path to the orbit. It acted as a weapon in the back in the olden days. There used to be a knife. There used to be a knife or a blade attached to a spring, and the person would, spin that weapon really, really fast. And then when he releases it, all he has to do is stop putting the centripetal force on the knife. Once he stopped putting centripetal force on the knife automatically started moving forward really fast. Understood? This is how the tangential this thing works. Drupad, if you understand, please let me know that. I cannot see your face. Since I can't see your face, it becomes really hard for me to observe what you're doing. Okay. Earlier, we have studied that acceleration of a body. One second. Okay. Earlier, we have studied that acceleration of a body moving in a circle of radius r with uniform speed is given as v square upon r, or omega square r, right? Acceleration, centripetal acceleration. In the previous chapter, we studied that centripetal acceleration is given as v square upon r or omega square r. Now, what is force? Force is mass times acceleration, right? Force is mass times acceleration. So the centripetal acceleration will become what? M v square upon r. Understood? That is the formula for centripetal acceleration. So force is equal to m v square upon r, where m is the mass of the body. This force directed forward the center is called the centripetal force. Now, but v square upon r is a centripetal acceleration or a radial acceleration. That is, centripetal force Fc is equal to m omega square r. Why? Because we know that v is equal to the linear velocity has a relation with the angular velocity by the formula v is equal to r omega. Therefore, the formula becomes m omega square r. For example, for a stone rotated in a circle by a string, the centripetal force is provided by the tension in the string. The centripetal force for the motion of a planet around the sun is the gravitational force on the planet due to the sun. Okay, the centripetal force on Earth is being acted upon by the gravitational force that exists between the Earth and the sun. For a car taking a circular turn on the horizontal road, the centripetal force is the force of friction. We are going to learn more about this. Whenever we are traveling on a road, the inward force provided by the inverse force is provided by the frictional force that exists between the tires and the road. Okay, it exists between the tire and the road. That is why we are able to rotate. That's why we are able to turn ourselves. Understood? So if there is no friction between the road and the vehicle, then the vehicle will not be able to turn itself. Even turning is helped by friction. Okay, an artificial satellite of mass 3,500 kgs is orbiting around the Earth with a speed of 4 kilometers per second at a distance of 10 to the power 4 kilometers from the Earth. Calculate the centripetal force acting on it. First, we will calculate the centripetal force. Okay. Okay. So we know that centripetal force is given as what? F is equal to mv squared upon r. But none of the units here are actually given in SI units, right? This is not in SI unit. We have to convert all of these into SI units first. Okay, so mass is how much? 2,500 kgs. Then you have V, speed is equal to 4,000 meters per second. And basically distance, R is equal to how much? 10 to the power of 4 multiplied by 1000, which is 10 to the power of 7 meters. So when we put all of them together, what do we get? Force is equal to 2500 multiplied by 4000 in the whole squared upon R. R is how much? 10 to the power 7. 10 to the power of 7. So that's it, right? Yeah, 10 to the power of 7. So 2500 multiplied by 16000000 upon 10 to the power of 7. So 1, 2, 3, 4, 5, 6, 6 and 1. This gets cut off. So 250 multiplied by 16. 200 multiplied by 16, 250 multiplied by 16, you will get 4000 newtons. Understood? 25 multiplied by 4 is 100, 25 multiplied by 8 is 200, 25 multiplied by 16 is 300, 25 multiplied by 4 is 1600. So basically 25 250 multiplied by 16 is 4000 newtons. Understood this question? Drupad, did you understand this? Okay. Drupad, I really want you to repair your webcam. Okay. It's becoming very difficult. Or buy a new, buy a small webcam that you can actually connect to your laptop. Interesting applications of motion on a circular path. Following are the interesting applications of motion of a body on a circular path. Number one, circular motion of a car on a level road. Okay. Now, when a vehicle goes around a curved road, it requires some centripetal force. While rounding the curve, the wheels of the vehicle have a tendency to leave the curved path and regain the straight line path. The force of friction between the road and the tires provide the centripetal force required to keep the car in motion around the curve. Okay, so if this is your road, okay, wait, hold on, like this. Yeah. So a car which is traveling like this, if it wants to travel like this, it was initially traveling straight. Okay, it was initially traveling straight. Now, who has to see? Basically, if you want to turn yourself, you need some centripetal force inwards. Okay, without having the centripetal force directed inwards, the vehicle cannot turn itself. Okay, now the steering, what are you doing? You're turning the wheels of the car with the help of your steering in the direction in which we want to steer. But the vehicle still wants to go forward. So, who is providing the centripetal force? The centripetal force is being provided by the friction that is happening between the wheels. Okay, it is happening between the wheels and the surface, and this frictional force is acting as the centripetal force. Okay, so there are three forces acting on the car, such as the weight of the car mg acting vertically downwards, the normal reaction of the road on the car acting vertically upwards, and the frictional force F along the surface of the road, that is towards the center of the turn. So you are having, if this is the vehicle and this is the surface, it is having a weight, a normal reaction, and a frictional force which is acting as a centripetal force. Understood? These are the three forces that are acting on it. Let us consider a car of weight mg going around a circular level road of radius r with a velocity v as shown in the above figure. While taking the turn, the tires of the car tend to leave the road and go away from the center of the curve. Okay, they want to leave the road and move straight. They don't want to actually go into the curve. Okay, next, as there is no acceleration in the vertical direction, what is happening? The object is not moving up or down. Because it is not moving up or down, what happens? It does not have any vertical force. And not having a vertical force leads to what? R is equal to mg. R, the normal reaction becomes equal to the weight of the object. So R becomes equal to mg. For circular motion, the centripetal force is along the surface of the road towards the center of the turn. The static friction opposes the impending motion of the car moving away from the road. Thus, what happens? mv square upon r becomes less than or equal to f. Here, f is what? F is our frictional force. Okay, you can have a maximum centripetal acceleration. Okay, maximum centripetal force will be acted inwards will always be less than or equal to the frictional force. Understood? The friction, you cannot basically have a centripetal force greater than the frictional force, because the only thing that is providing you with centripetal force is the friction. So the maximum limit of centripetal force will be the frictional force that is acting between the tires and the road. Okay, now you must have seen F1, right? Do you watch racing competitions and all? racing competitions? Huh? Drupad, are you listening to me, Drupad? Because I sure, right? Okay. So yeah, what is happening there? There is a loss in motion. Okay. Whenever the driver tries to take a turn with a velocity greater than the center than allowed by the centripetal force, what happens? His car just collides on the bank, right? Straightforward, it will just collide. It will he will be out of the race. Now that is the reason. See, centripetal acceleration, centripetal force. The centripetal force cannot be greater than frictional force. Understood? It can be equal to the frictional force. It can be less than the frictional force, but it can never be greater than the frictional force. Where V is the velocity of the car while turning, and R is the radius of the circular track. Understood? V is the velocity of the car, R is the radius of the circular track. Now, F is equal to mu S of R. We know this, right? We know that static friction f of s is equal to what? Mu s. Mu of s is how much? What? The coefficient of static friction. And r is the normal reaction. But as we have already discussed that there is no vertical motion, therefore the normal reaction becomes equal to the weight of the object. Okay, so f becomes equal to mg. Now let us actually compare these two. Okay, we know that m v squared upon r should be less than or equal to the frictional force. Okay, now mv squared upon r should be less than or equal to mu of s r, or mv squared upon r should be less than or equal to mu mg. M and m gets cancelled off. So what are you left with? V square upon r should be less than or equal to mu g, which gives us V square is equal to mu of s r g. This is all mu of s. Okay, mu of s. Mu of s r g. Therefore, V becomes root under mu of s r g. Clear? This is the maximum velocity that you can have. Should be less than or equal to. It should be less than or equal to. Okay, it is the maximum velocity with which you can turn. Understood? If you go over this, what will happen? The centripetal force won't be able to, the centripetal force provided by friction won't be able to sustain you in that racetrack, in that curve. Understood? You will basically start to slide. The frictional force is not enough for you to keep you in the turn. Therefore, you will start to slide. Without sliding, if you want the vehicle to travel, you have the velocity v is equal to root under mu of s rg. Clear? Is this clear, Drupad? Okay, I don't want you to remember this formula. I just want you to understand the concept, because when the class finally gets over, in the final exam, there will be so many formulas that you have to remember that it will become difficult for you. There are chapters in which you have more than 30, 40 formulas. Okay, so there are some formulas that you have to remember. There are some formulas that you can derive. The formulas that you can derive on your own should be the ones that you don't have to remember. Okay, all you have to remember is the concept that the centripetal force is being provided by friction. Centripetal force is mv square upon r. Frictional force is mu sr or mu smg. Compare these two, what do you get? mv square upon r should be less than or equal to mu s mg. Gets cut off, that r goes here. So v square is equal to mu s r g. Therefore, v becomes equal to root under mu of s r g. So this is how you remember a formula, by knowing the actual derivation behind it. You should be able to derive these formulas in your head so that you don't have to remember the final formula at the end. When the chapters are less, okay, when the chapters are less, it is easy to just remember all the formulas. But when you, in the final exam, when you have 14 chapters all in all, then it will become a big hurdle for you. A bend in a level road has a radius of 100 meters. Find the maximum speed which a car turns this bend may have without skidding if the coefficient of friction between the tires and the road is 0.8. The maximum speed which the car can have without skidding is given as mu is equal to v square upon rg, where v is equal to root under mu rg. So we can find the formula. Everything has been given to us. The radius has been given to us. Okay, now the coefficient of static friction has been given to us, as well as we know the value of g. Since everything is given, we can simply calculate. It's a direct formula based questions. Any doubt in this question? Nothing, right? No? Okay. Now, a cyclist speeding at 18 kilometers per hour on a level road takes a sharp circular turn of radius 3 meters without reducing the speed. The coefficient of static friction between the tires and the road is 0.1. Will the cyclist slip while taking the turn? Okay, so first and foremost, we have to figure out how much is the friction there. How much friction does it have? What is the maximum velocity that is allowed by the road for such a static coefficient? So when you do that, what do you get? Look at this. So he is traveling with a velocity of 18 kilometers per hour. If you convert that into meters per second, what do you get? 18 kilometers per hour becomes 5 meters per second. 18 kilometers per hour becomes 5 meters per second. Now, next thing, radius has been given as 3 meters. Okay, the coefficient of static friction between the tire and the road is mu of s is equal to 0.1 and nothing else. Okay, we'll take the value of g as 10. Let's take it as 10. Okay, so r, mu s and g. We know that the maximum velocity allowed for such categories r, mu of s and g is known as is given as root under mu s rg. So v becomes equal to root under 0.1 multiplied by 3 multiplied by 10. So v becomes root 3, right? V becomes root 3. What is the value of root 3, Drupad? 1.732. Okay, that is the maximum allowed speed. Okay, 1.732 is the maximum allowed speed for that vehicle. Therefore, what will happen? He will slip because he is trying to go at 5 meters per second, but the road is only allowing you a maximum velocity of how much? 1.732 meters per second. So he will definitely slip. The condition is not satisfied, hence the cyclist will slip. Now, the next topic that we are going to do is the banking. Okay, the banking section, it has a derivation which is for 3 marks, and I think from this chapter that is one of the most important derivations ever, where we have to calculate the velocity of an object when it is moving on a banked road. What is the meaning of a banked road? A banked road is a road that is not actually horizontal with the surface of the earth. It has a certain angle. Okay, it has a certain angle with the surface of the earth. That is, this angle theta is known as angle of banking. Understood? This is known as angle of banking. So basically, instead of driving on a level road, the object is now going to travel like this. Okay, so basically, instead of turning like this, they're going to turn like this. Okay, at a certain angle. Now, this is known as banking motion. Now, why do we have banks in the first place? So, Drupad, you can see that we know the turning is helped. Okay, it is helped by friction. Friction is providing the centripetal force required to turn. Now, if only friction is responsible for turning, then every time we are turning, the our tires or whatever circular surface that we have, it is getting what? It is getting rubbed over, and there is going to be wear and tear, due to which what happens? The object's surface won't last for a long time. Usually what happens after like 10,000 kilometers, the vehicle's tires go bald. That is, their grooves become, their grooves disappear, due to which what happens, the tires become unsafe for riding. So a large amount of wear and tear is caused whenever we are turning. So if we can reduce the friction required to turn and use some other type of force for the actual turning part, would that help our tires? Obviously it will help our tires, right? Now then another type of force that is being that is aiding us while turning is given as the normal reaction. Okay, let's see how that happens. Okay, to avoid this, the curved road is given an inclined slope upwards towards the outer circumference. This reduces wearing out of tires because the horizontal component of normal reaction provides the necessary centripetal force. The system of raising the outer edges of a road above its inner edge is called banking of the curved road. Okay, this process is known as banking of the curved road. So the angle through which the outer edges of the curved road is raised above the inner edges is known as angle of banking. Okay, now the motion is known as banking of the curved road, and the actual angle onto which the road is banked upon is known as the angle of banking. Now let us consider a car of weight mg going along a curved path of radius r with speed v on a road banked at an angle theta as shown in the following figure. What happens? The force acting on the car, there are multiple forces acting on the car. I'm just going to draw them all. Okay, so this is the surface, this is the road, and this is the angle of banking theta. Okay, now Drupad, I want you to answer quickly. Okay, now look at the screen. You have this object like this. Now, what is this force, Drupad? Drupad, speak a little bit louder. I can't hear you. MG. Okay. Now, what is this force? The normal force R. Okay. Now, I want to resolve. What is one more force? What is this force, Drupad? Yeah. A frictional force always parallel to the surface. Okay. I want to resolve all these forces in the horizontal and vertical direction. Now, what will this angle be, Drupad? What will this angle be? Oh, this angle will be theta, right? Whatever angle you have here is going to be the same angle here. Why? Because if this is theta, this is 90 degrees, this becomes 90 minus theta. We know that the R is always perpendicular to the surface. Therefore, we know this angle is also 90 degrees. And so we have three angles in the same line. Okay, this angle, and we know this is 90 minus theta. This is 90 degrees, and this is x. Now, if we add all the three angles up, you should get 180 degrees because it's a straight line. So, x plus 90 minus theta is equal to 180 degrees. This 90, and this 180 gets cut off. Therefore, you get x minus theta is equal to 180 degrees. Therefore, x minus theta is equal to 0, Therefore, x becomes theta. So, this is how you are getting the angle theta here. Understood? This is how you are getting the angle theta here. Next. Yeah. So I'm going to resolve my mg is no mg is okay, mg is fine. So I'm going to resolve this value of r here as r cos theta and this as r sine theta. The frictional force can also be resolved as, if this is theta and mm, this also becomes theta, right? Because these two are what? Corresponding angles, sorry, alternate interior angles, right? Both of them are theta. So this becomes f cos theta, and there is another downward force called F sine theta. Understood? This is how all the forces are being acted on by the or acted on the object. Now, so what are the forces that are acting downwards? F sine theta and mg. What are the forces that are acting upwards? R cos theta. What are the forces that are acting inwards? R sine theta and F S cos theta. Okay, sorry, F cos theta. Now, let us equate all of these. We are going to equate all of them. Understood? How do we equate them? So, R cos theta is equal to mg plus R sine theta, right? The R cos theta, the up. Oh, sorry. I'm so sorry. F sine theta, yeah. F sine theta. Okay. Now, similarly, you have R sine theta plus F cos theta is equal to the centripetal force, which is equal to mv squared upon R. That is the centripetal force. Now, we know that force is equal to, okay, the frictional force is equal to what? Mu of S multiplied by R. So I'm going to put this value of F in this equation as well as in this equation. Okay, so you get R cos theta is equal to mg plus mu of S R sine theta. Similarly, you have R sine theta plus mu of S R sine theta is equal to m v squared upon R, the radius. Next. Oh, careless mistakes again and again. Mu of S R cos theta. Okay. So I'm going to take from this equation, I'm going to take the R out. Okay. I'm going to bring this here. R cos theta minus mu of S R sine theta is equal to mg R cos theta minus mu of S sine theta is equal to mg. Therefore, what do you get? R is equal to yeah, R is equal to mg upon cos theta minus mu of S sine theta. Okay, any doubt still here? Okay, now I'm going to put this value in the second equation. Okay, like this. I'm going to take the R out first and then I'm going to put the value. So I'll get, okay, so R sine theta plus mu of S cos theta should be equal to mv squared upon R. So this becomes mg upon cos theta minus mu of S sine theta into sine theta plus mu of S cos theta is equal to mv squared upon R. Can I cancel this m on both sides? Okay, now I'm going to take this R and basically place it here. So Rg sine theta plus mu of S cos theta upon cos theta minus mu of S sine theta is equal to v squared. Now, v becomes equal to what? V is equal to root under Rg sine theta plus mu of S cos theta upon cos theta minus mu of s sin theta. This is an absolutely okay formula. Okay, but there are a lot of trigonometric identities here. So what do we do to make it simple? Inside this square root, what do? We divide the numerator and the denominator by cos theta. Okay, so what do we get? V is equal to root under Rg sin theta upon cos theta plus mu of s cos theta upon cos theta. Okay, all I have done is divide the numerator and the denominator by cos theta. That's it, nothing else. Upon your cos theta upon cos theta minus mu of s sin theta upon cos theta. Clear? So I get V is equal to root under Rg tan theta plus mu of s, because cos theta and cos theta get cancelled here also upon 1 minus mu of s tan theta. To make the numerator and the denominator more familiar, what do? V is equal to root under mu of s plus Rg. No. No, wait. Rg is inside. Wait. I made a small mistake. Here, this will become, yeah, much better. So, mu of s plus tan theta multiplied by Rg upon 1 minus mu of s tan theta. Okay? This is how you get the formula. This whole derivation. Okay? This is a 3-marker derivation. At least 2 to 3 marks you can expect. Any doubts here? Okay, let's move on. Now, special cases. What happens when the friction reduces to 0? Okay, in this previous formula, what happens if the coefficient of friction becomes 0 in this whole problem? This thing. This is the formula, right? So, if mu of s is equal to 0, then v becomes equal to what? Root under 0 plus tan theta Rg upon 1 minus 0. So you end up getting V is equal to root under Rg tan theta. Clear? So even if you don't have friction, this is just to show that even if you don't have friction, you can still rotate, you can still move around if basically, once again, yeah, you can still move around just by having the normal force with 0 friction. This is the formula. Okay, clear? Rg tan theta. Now, what is the angle? How do you find the angle? If you know the velocity, if you want to design a racetrack and you want the cars to go at certain speeds, okay, and you consider the resistance, you consider the friction to be almost negligible. Okay, sometimes that happens when you design. You have to make sure that the maximum speed. What if it's raining? What if the roads become slippery? What if the resistance actually becomes 0? What is the required velocity that you need to make the turn? Okay, let's actually look at that. So we know that V is equal to root under Rg tan theta, right? Let's square on both sides. What do you get? V square is equal to Rg tan theta. Therefore, tan theta is equal to V squared upon Rg, or theta is equal to tan inverse V square upon RG. Understood? This is the angle that you will need to design your racetrack, to design the roads, to for construction and all that other stuff. Okay. Next, a circular racetrack of radius 300 meters is banked at an angle of 15 degrees. If the coefficient of friction between the wheels of the race car and the road is 0.2, what is the optimum speed of the raced car to avoid wear and tear of its tires? And number two, the maximum permissible speed to avoid slipping. The angle has been given as how much? 15 degrees. So shall we write the formula first? So what is V max? What is the formula? Do you remember it now? Root under Rg mu of S plus tan theta upon 1 minus mu of S tan theta. Okay, now let's actually put the values. Tan theta is how much? Oh, 0.2679. Couldn't give us a simpler value. Okay, 300 meters. Okay, so V max is equal to root under 300 multiplied by, I'm going to take the value of G as 10 to make it easier. So, mu of S is how much? Wait. Hold on. Okay, fine. Let's calculate the safe speed first. Okay. The optimal speed of the race car to avoid wear and tear of the tires. That's what we were doing, right? Oh, V not without the actual friction and all. Okay, fine. V is equal to root under Rg tan theta is equal to root under R is how much? 300 into 10 into your 0.2679. 0.2679. So 267.9 267.9 multiplied by 3 root. This is the value that you'll get. Okay, 1 second. 267.9 multiplied by 3. 28.34. Yeah, 28.34. We use 10 instead of 9.8, so they are getting a different value. We are getting a different value. 28.34 meters per second. This is still fine. Drupad, I'm still telling you, the values can change slightly. If the value of G is not given to you, you can take whatever value of G you want. Okay, it can either be 9.8 or it can be 10 meters per second. So don't stress yourself out saying that, oh, my value is changing if I take the value of G as 10. No, it won't change. Clear? The maximum permissible speed. Okay, let's actually figure out. So V max is equal to how much? V max is going to be Rg mu of S plus tan theta upon 1 minus mu of S tan theta. So this becomes equal to root under 300 multiplied by 10. Mu of S is 0.2. 0.2 tan theta is equal to how much? 0. What is tan theta? 0.2679 multiplied by 0.2679, the whole upon 1 minus 0.2 into 0.2679. Okay, so what do we get? What do we get? Okay, root under 3000 multiplied by 2679. Okay, What is 0.2 multiplied by 0.2679? Hmm. Hmm. अरे यार 2 Is it correct? What is the value of mu of s? Mu of s is correct. Oh my god, I'm such an idiot. I wrote the formula correctly, but still I implemented it wrong. Root under G R uh, mu of s plus tan theta upon 1 minus mu of s tan theta is equal to R is 300 multiplied by 10, 0.2 plus 0.2679, 0.2679 upon 1 minus your 0.2 multiplied by 0.2679. And we're going to use the calculator. Okay. Yeah. So roughly you will get how much? 1403.4 divided by 0.94, 0.94642. Okay, root under 1482. 1482. 38. Yeah, 38.1 meters per second. Okay. So I don't think they will ask you like such complicated numbers in the exam. Okay. But they shouldn't actually. You're not allowed to use a calculator in school, right? You are not allowed to use a calculator in school, right? Okay. Okay. Drupad, let me know when you have to leave. Okay. I'll forget. Okay. Whenever you want to get ready, you just let me know. Now, the radius of curvature of a railway track at a place where the train is moving at a speed of 72 kilometers per hour is 625 meters. The distance between the rails is 1.5 meters. Find the angle and the elevation of the outrail so that there may be no side pressure on the rails. Take G as 9.8 meters per second. We need to find the value of theta now. Okay. Okay. B is equal to 72 kilometers per hour is equal to 20 meters per second. Okay. Next, uh, R is equal to 625 meters. The distance between the rails is 1.5. Okay. Find the angle and the elevation of the outer rail so that there may be no side pressure on the rails. Why did they give us the distance between the rails? Also, they haven't given us, oh, no side pressure at all. Okay. But why would they give us the distance between the rails? We know that B is equal to root under uh, RG tan theta, that we know. But why would they have given us the distance between the rails? Oh, 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 we have to find the angle and we have to find this. We have to find this. This is the elevation that is required. That is why they gave us the distance between the track. This is application of trigonometry, class 10th. Okay. So you have 1.5 meters here. I was also thinking, why did they give us this? Because they want us to calculate this, not just theta. They want us to calculate the height also. See, Drupad, if you calculate theta, then by just using tan theta is equal to opposite side upon adjacent side, you will get opposite side is equal to adjacent side tan theta, right? That is the reason why they gave us the distance between the rails. Okay, I just didn't I just couldn't picture like they were asking this question or not. Okay, now let's actually try to calculate. B is equal to root under radius is 625 multiplied by oh G is 9.8. Fine, 9.8 multiplied by tan theta. So B is how much? 20. 20 is equal to. So I'm going to square both sides. So 400 is equal to 625 multiplied by 9.8 multiplied by tan theta. Tan theta is equal to 400 upon 625 multiplied by 9.8. Okay. So, I can cut this off with 25, right? 25, 16, 25, 4, this is the 25 to 25, 25 multiplied by 9.8. Tan theta is equal to 16 upon 25 multiplied by 9.8. Theta is equal to tan inverse um, 16 upon 25 multiplied by 9.8. 16 divided by 25 is equal to divided by 9.8 is equal to, so theta is equal to tan inverse 0.065. Therefore tan inverse 0.065 is equal to 3.71. 0.71. Is the value of 3.71 degrees correct? Yeah, 3.74. I'm getting 3.71 degrees. Okay. Next, what do? We have the angle. Now we need to find the height. So we know that tan theta is equal to opposite side upon adjacent side. Now we know the adjacent side is what? The distance between the two rails, right? So the distance between the two rails is how much? 0.1.5, sorry. So 1.5, and opposite side is h, and tan theta is how much? 0.065. 0.065. So h is equal to 1.5 multiplied by 0.065 is equal to 0.065 multiplied by 1.5 is equal to 0.09. Wait, what? Is it correct? Yeah, that is correct. Or roughly 9 centimeters. Understood? So, did you understand why they gave us the distance between the two tracks? Drupad? Okay. Okay. So, one second, what is the time right now? Do you have to leave now? 11 o'clock, right? Till 11 we can take the class? Okay, fine. If a car if a car having speed 50 kilometers per hour can round the curved bank at an angle theta, find out the value of theta if the radius of the curve is 40 meters and consider the friction is negligible. If a car having a speed of 50 kilometers per hour can round the curved bank at an angle theta, find the value of theta if the radius of the curve is 40. Okay, and consider the friction to be negligible. Oh, very good. So we know that V is equal to root under Rg tan theta. So V square is equal to Rg tan theta. Now V is how much? 50 kilometers per hour. Oh, how much is 50? 50 into 5 upon 18, the whole square is equal to P R is how much? 40 multiplied by, uh, let's take it 10 only. Okay. 14 multiplied by 10, tan theta. So 50 multiplied by 5 upon 18, the whole square multiplied by 1 upon 400 is equal to tan theta. So 50 into 5 is 250 upon 18, the whole square multiplied by 1 upon 400 into tan theta. So what do you get? 20 upon 18 is 125.9. And this one used to 250 divided by 18 is equal to 13.8. The whole square is equal to 192 divided by 400 is equal to 0.4822. 0.4822 is equal to tan theta. Therefore, theta is equal to tan inverse 0.4822. So tan inverse 0.4822 equals 25.74. Is it correct? Yeah, 25.74 or 26.18. They have taken 9.8, I have taken 10. Okay, so you will get 25.74. Theta is equal to 25.74 degrees. Clear? Okay, you can directly use the formula V is equal to Rg tan theta. We are using the same formula, right? Yeah, okay. Next, a wooden block of mass 2 kg rests on a soft horizontal floor. When an iron cylinder of mass 25 kg is placed on top of the block, the floor yields steadily and the block and the cylinder together go down with an acceleration of 0.1 meters per second. What is the action of the block on the floor before and after the floor yields? Identify the action reaction pair in this problem. Uh, okay. When an iron cylinder of mass 25 kg is placed on top, 25 kg is placed on top, together they go down. How do they go down? When an iron cylinder of mass 25 kg is placed on top of the block, the floor yields. Oh, the floor is going. Oh, it's a depression. The floor yields steadily, and the block and the cylinder go down with an acceleration. They're going down with an acceleration a is equal to 0.1 meters per second square. What is the action of the block on the floor? Action means what? The weight, right? The action is how much? Mass times acceleration, right? So, yeah, once again, a wooden block of mass 2 kg. So, Drupad, have you ever gone to the beach? Yeah, on the beach, whenever you place your feet on the sand, what happens? The sand depresses itself. It creates a small depression in the downward direction. Similarly, what is happening? You have a 2 kg block on top of which a 25 kg cylinder is placed. Due to which what happens? There is a slight depression in the ground. So basically, they are moving downwards. Okay, they are moving downwards with an acceleration of 0.1 meters per second. Okay, they are moving downwards. That's what's happening here. Did you understand the question now? Okay, what is the action of the block on the floor? What is happening here? The action of the block will be a what? It will be the weight, right? There is nothing else going on. So the action on the block will be the weight. So we know that 25, it is the, what is the mass? Uh, before and after the floor yields. Okay, see, before the floor yields, what happens? Before the what? Yeah, before the floor yields, R is equal to mg. Okay, that means there is no acceleration. R minus mg is equal. We know that R, if it is going downwards, okay, we know that if an object is going downwards, then we know that the downward force minus the upward force should be equal to ma. If something is going upwards, we know that upward force minus downward force is equal to ma. right? This is how the two formulas. Do you remember the lift problem? Right. In the lift problem, that's what we did, right? Downward forces here is mg, but before the flow yields, the downward force minus the upward force is equal to 0. In this case, downward force minus upward force equals 0. Therefore, downward force is equal to upward force. Understood? Downward force is becoming equal to the upward force. R is becoming equal to mg. Okay, so the action reaction pair becomes equal to how much? 25, right? 25 plus 2 into I still have a small problem here. The floor on, oh my god, they should have, see Drupad, the floor only started to yield when you placed the 25 kg block over it. Okay, the floor did not yield when you only had a 2 kg block on the surface. Okay, so that is the reason. Before the floor yields, the downward force is how much? Huh? The mg, it is equal to the weight, is is equal to mg is equal to how much? What is the mass? 2 kgs. 2 multiplied by 10 is equal to 20 newtons. Okay, now after the floor yields, what is the action of the block on the floor after the floor yields? Now, after the floor yields, what happens? You now have the weight to be equal to how much? Weight of the combo will be equal to 2 plus 25 multiplied by 10 is equal to 270 newtons. This is now the new weight. Okay, now we need to find the R dash. So after the floor yields, what is the action of the block on the floor before the floor yields and after the floor yields? Now, after the floor yields, we know that the downward force minus the upward force should be equal to ma, right? The downward force minus the upward force should be equal to ma. Downward force is 270 minus the upward force is the normal reaction should be equal to ma should be 25 multiplied by 0.1. So r dash, oh sorry, I'm sorry, 27 27 multiplied by 0.1. So r dash becomes equal to what? 270 minus 2.7. 270 minus 2.7. So basically, R dash is equal to 270 to 278. So sorry, what am I doing? 268.3. 267. 267.3 newtons. Understood? Okay. So, did you understand the logic behind the depression? The depression was only happening because of the excess weight. Because of the excess weight, you are putting a tremendous amount of pressure on that particular spot, due to which it started going downwards. Okay. Now, I think we have time for one more problem. Let's do it. Consider two masses m1 and m2 connected by a light and extendable string passing over a smooth light pulley which is fixed by a rigid cord from a rigid support as shown in figure. This device is also known as Atwood's machine. Find the tension in the rope and the acceleration of each block. Have they given anything else? M1 and M2 by a light inextendable string passing over a smooth pulley is fixed at a rigid spot. The device is known as Atwood's machine. Find the tension in the rope and the okay. First things first, we are going to consider that M2 is greater than M1. Okay. That is the first thing that we consider. Now, Drupad, if you have a machine like this, if M2 is greater than M1, so this will go downwards and M1 will go upwards, right? This will go downwards and this will go upwards. Now, let us draw a free body diagram for this. Okay. We know that the pulley is rotating like this because this mass is coming down, this mass is coming up. Okay. Now, since the overall motion in this side of the pulley is downwards, can I write this is M2G downwards? This is what? My tension. Okay. And this tension is being exerted on this also. Okay. So, this is what M1G, and this is again tension. Clear? The same tension is going in both the sides. No, wait. Is it? Yeah, because it's just a one single string, right? So I can write mg minus t should be equal to m2g minus t should be equal to ma, and um, t minus m1g should be equal to ma. Here also I have to change uh, m2 into a, and this becomes m1 into a. Did you understand the logic here? The tension in the rope is the same. Okay, the tension in the rope is the same. This is going downwards. Since this object is going downwards and this is going upwards, the downward force minus the upward force should be equal to ma. The upward force minus the downward force should be equal to ma. Now I am going to basically add these two equations. Okay, so I'll just rearrange them like this and use the linear equation in two variables method to eliminate the value of t. So minus t plus m2g equals m2a, and t minus m1g is equal to m1a. So I add them up. What do I get? This cut gets cut off. M2g minus m1g is equal to m2a minus m1a. So m2 minus m1 into g is equal to m2 minus m1 into a. What? So G becomes equal to A. Is that correct? Did I make a mistake somewhere? Hmm. God, Drupad, why didn't you tell me? Why didn't you tell me I'm such an idiot? I am adding these two equations, no. So M2G minus M1G is equal to M2 plus M1 into A. I really have to stop taking shortcuts. Understood? So this won't get cut off. m2 minus m1 into g is equal to m2a plus m1a. m2 plus m1 into a. So your a is equal to m2g, sorry, m2 minus m1 into g upon m2 plus m1 into a. Oh, sorry, just this much. Okay, yeah, that's it. Now what do you have to do? Okay, we have found the acceleration. Now we have to find the tension on the rope. Okay, so let us use any of the formulas. Okay, so m2g minus t is equal to m2a minus t is equal to m2. What is the value of a? m1 minus m2 minus m1 upon m2 plus m1 into g. So m2g minus m2 minus m1 upon m2 plus m1 into g is equal to t. Okay, so m2 minus m2 minus m1 upon m2 plus m1 into g is equal to t. Okay, we're almost there, almost there. m2 into m2 plus m1 minus m2 plus m1 upon m2 plus m1 into g is equal to t. Did this stop it here itself? I think this should be enough, right? How are they calculating tension? Huh? Yeah, but oh, you have to go? Okay, 1 second. So we'll continue this video in the next class. Okay, we'll finish this problem in the next class. Okay, thank you and have a nice day. If you like my video, please like, share, and subscribe. And see you in the next video.